Hi folks, welcome to our second and final stop of the day. We are in Marshall, Illinois, taking a look at a soybean trial. In this one, we're going to see an untreated check, our 401 product that's commercially available, and 2 pipeline products as well. So I'm going to have Kyle kind of give an overview of what we're going to do at this location as far as testing goes.
Yeah, so real similar to the last one that we did earlier, obviously just different crops. So we'll be doing root digs, tissue tests, stain counts, and plant height measurements as part of our first visit. So we'll run through that. Like Erica said, it's going to take a little bit longer. We got a lot of treatments here. So just as a heads up, on Sunday afternoon, we got a phone call from the farmer, and he said, "Hey, I don't know if you guys want to come out here. Beans don't look so hot." And we're like, "Uh-oh, what happened?" Right? So what happened was he came out here, sprayed some Flex Star, controlled some water hemp that he's had coming in. So beans are burnt, but just in NewLeaf fashion. You know, they want to be candid. This is real world and real world environment. And so through pictures and stuff, you might be seeing some bronze and burns beans, but they're already starting to grow out of it. They were sprayed, I think they had sprayed almost a week ago or so now. So just working with what we got, and just wanted to give an update on why they look the way they look.
Yeah, and we're going to let Kyle go because there's a lot of digging to do, but Allison and I are going to talk a little bit about mode of action while he goes and digs all the plants. And before you run off, actually, Kyle and Allison, if you want to come look too, we did a really quick look. The farmer came out with us today. We did a super quick look at just what we were seeing above and below ground. And like Kyle mentioned, they do have a little bit of burn on them, but that's clearly not impacting what's happening below the soil. So any kind of thoughts from you, Kyle, on what you're seeing here?
Oh, this is typical. I mean, there's nothing shocking about what we're seeing here. I mean, Flex Star is known to burn, not in all situations, but in this particular situation, whatever the spray conditions were, it was conducive to burning the plants. So this is, anyone who's sprayed Flex Star, this is nothing that's of any surprise. So the good thing is that, I mean, they're not severely burned. They'll grow out of it. I mean, you're already starting to see some of the new growth here. And so your growing point wasn't even affected at all. So they'll grow out of it, no problem.
Awesome.
Probably even see a little bit of increased branching out of the stress that it went through. So
Kyle will definitely keep us posted as he comes back throughout the year. Awesome. Well, you go ahead and get on digging. We'll come join you in just a second.
Sounds good.
All right, so that was a nice little preview for y'all, just to see what we're looking at this trial specifically. To kind of talk about that we didn't hit on when we were in our corn trial was mode of action, or as something we like to talk about at NewLeaf, modes of action, as in multiple. So Allison, how about you, for everybody tuning in, just give us the 411 on how do M-trophs work?
Exactly. Okay. Well, so of course it's complicated. I'm a scientist, so I can give you the complicated answer. But when in NewLeaf in their early days did a lot of like prospecting in terms of building the collection. So when new M-trophs came in from what they called the strain safari, they were rigorously categorized by their ability to produce siderophores and by their ability to produce known plant hormones like auxin and other types of beneficial compounds, secondary metabolites. So within our proprietary prescriptives biologics knowledge base, which is our like internal discovery tool, we have a comparative genomics platform. Every single one of our isolates is fully sequenced and annotated, and we can go in and look at those genes and have a pretty good idea of what types of pathways may be present. So with the genetic knowledge or the genomic knowledge, and then also the extensive strain phenotyping that we did, and we as in not me, but like a whole team of people, we have a pretty good sense of their ability to impact different types of plant phenotypes. So like for example, something like a siderophore producer, so an M-troph that produces siderophores is actually able to more effectively scavenge iron out of a soil profile and then accumulate that iron back closer to the rhizosphere, which then as it's cycling, as the microbes live and die and their nutrients are kind of burst open when their cells die, that makes it more available to the plant. And for something like an M-troph that actually produces auxin, that's a plant hormone that influences growth. So it's not the same as applying a plant hormone to the field. Obviously, it's made by the microbe in close association with the root. So those are two of the multiple modes of action. And again, a lot of these, since there are multiple modes of action, it is difficult to pin down exactly which one we're seeing. And that's what's so exciting about these trials, is that as we start to look at performance over different soil types and different environmental conditions, taking all the information that we're gathering from these trials with intent and then cross-referencing that with our internal prescriptives biologics knowledge base, we're really excited to see how even better we can understand these individual M-trophs and how they're influencing the plant, and how we can use that knowledge to really drive the pipeline of discovery for next-gen products.
So we talked a little bit earlier today about capturing tissue samples for nutrient testing, and you just spoke a little bit about how those siderophores can go out and collect iron and bring those into the plant. Is that something that you would anticipate, as we're collecting samples on the soy side, that we would really be able to pinpoint down as we kind of move through this trial program? Or maybe I can already see the hesitancy in the scientist side wanting the big data set.
So we'll find out. We'll find out.
So maybe we wouldn't find out, but it would at least maybe lead us down the right direction to understanding that a little more.
Well, and again, like, it's something that when we have a controlled setting like the greenhouse, we have a pretty good understanding of which isolates have those phenotypes. But what we haven't done is take them out into the real world. And is that phenotype that we see in the greenhouse, does it perform that way on this soil type at this soil pH? And something that we have been able to do with our years of R&D field trial data is cross-reference the tissue nutrient data with soil pH and look at trends there. So we're very excited to have this data set, and it does really build on all of the controlled environment work that we've been doing as part of the discovery pipeline, and then just takes it into the real world.
Awesome. Well, thank you all for tuning in for the second half of our virtual field day. We're going to go meet Kyle in the field, offer some moral support, some biceps, a little extra help digging. We've got a lot to do at this one. 10 treated and untreated of each replication. So we're going to go start digging, and we'll share some stuff with you and be back live when we've got clean roots to show you.